All right, so directed line segments, now to kind of clarify exactly what it is we're talking about. A directed line segment is a segment that has distance and direction. Now, we talked about things having distance and direction before, and we called those vectors. So we're going to think of a directed line segment as a vector. Okay. So for our purposes, what this means is that if it's directed line segment AB, then we are starting at point A and going toward point B. So directed line segment AB and BA are not exactly the same thing. They might look the same on the page, but where you're starting from and the direction you're traveling is completely opposite. And the initial point for AB is going to be point A. So nothing super complicated with that idea. You just have to make sure you're reading and understanding which one is your starting point. Okay, it is important because when we partition, and that's the key thing. Notice below these diagrams, you can see that the line is being partitioned. So the whole idea about what we're doing now is we're going to be partitioning line segments. And when we do this, the ratio that we partition by will reference a starting point and a direction. Okay, and here's where, in practice, here's where it matters. So let's look at this example. We're looking now at this, for example, partitioning directed line segment AB into a 1-to-3 ratio implies that we start at point A and then have one part followed by 3 parts for a total of 4 parts. Now, if we change that ratio, we're not changing the directed line segment, it's still from A to B. But if we change the ratio to 3-to-1, then we would place the 3 parts first, starting at point A, and then the 1 part would follow. And we get 2 very different partitions this way. And in diagram form, that's what we're looking at here. Both of these are directed line segment AB, but the first one, you can see, has 1 part followed by 3, and then there's a partition point. The second one is a 3-to-1 ratio, so we've got 3 parts, a partition, and then 1 part following. So you'll notice the point that we use here is point P. So I'm going to circle that. We use P mostly because it's, we can think of it as the partition. Now, it's a point. We can name it whatever we wanted. But P is what we typically use. So this diagram is a little bit weird because it has a bunch of points on it and only one of them is labeled P. But as long as you understand that this is the point that matters, this is where we're actually cutting the line at, then you're good to go. Okay. So any questions so far? Okay, we can reference the same partition of a line segment by using the opposite endpoints. Okay, and we'll have a little, we'll have some practice on this on the back side, but you'll notice right here you've got the diagrams between these two are exactly the same. So both of these are interchangeable. But notice that the wording is very different. In the first one, we have directed line segment AB, and it's divided into a ratio of 1 to 2. So I'm starting at A. I go one part. There's partition point P, and then there's two parts following. This is directed line segment BA divided into a ratio of 2 to 1. Start at B, go 2 parts. There's my partition point, follow that up with 1. So if you look at the wording and how it changes between these two, what actually changed from the first to the second? So in the wording, what changed? There you go. We're taking the ratio and flipping it. What else is being flipped? Yeah, the line segment is flipping. You have some of those on the back side, so if you just remember this idea, when you look at those, it's not going to be that difficult. Okay, so you have 3 segments, directed line segments down here. They're all directed line segment BA. I want you guys just to take a minute and see if you can come up with the ratios where the partition is for all these line segments. Let me go ahead and have you guys call out what you got for the first one right here. What's our ratio going to be? 2 to 3 here. All right, so we have a 2 to 3 ratio, and you can see that right here that this is 2. After the partition, it's 3. So 2 to 3 ratio. Next one, what do we have? 1 to 1. All right, that one's easy enough to see, 1 and 1 right here. And then the last one, what do we have? Okay, and this is one you have to be careful with. Well, and a lot of people, not most, but a lot of people would want to say maybe 5 to 1. But remember, directed line segment, the starting point matters. This is directed line segment BA. We're starting at B, going right to left. That will happen, so you have to make sure that you're prepared for that. So yeah, we have your 1 right here. And then when you add this up right here, there's your 5. Okay, now we're going to be seeing ratios, but we're actually going to be looking at. We're looking at ratios, but we're actually going to be converting this before we move on. But for right now, I just want you still focused on ratios, making sure you understand the idea. And on the back side, you have a bunch of practice with ratios. Notice for number 1, all these are directed line segment AB. For number 2, they changed what the directed line segment is for each one. So you'll need to make sure you're reading that closely. And then when you get down to the bottom, you have some other problems that are similar to stuff we did on the front. So go ahead, try this entire page, and we'll just run through and get all the answers in a couple of minutes. Okay, so looking at these, what did you guys get as your ratio for 1A? 1 to 2. The next one, what'd you get? 3 to 1. The next one, 5 to 1. And these are all A to B. What did you get for the next one? 2 to 3. The next one, 1 to 1. And the last one for 1, 3 to 2. Okay, so hopefully everyone got that. And this isn't supposed to be like mind-blowingly difficult. So hopefully you guys are like, okay, yeah, it's straightforward. I get the idea. So the next one, the directed line segments change, so you have to make sure you're reading that carefully. That will probably be the only thing that screws you up on this. So 2A, what did you get? 1 to 3 is what you should have had. The 2B. All right, that is 1 to 4. And the next one, 2 to 1. All right, next one. Okay, 2 to 4. And I know that looks like it can be simplified, and we'll talk about that. The next one, 2 to 3, and the last one here, 4 to 1. So it's just important that you understand what it means with this ratio. And the last one right here, it already tells you you have directed line segment RF, partition 2 to 3. So how could you get the same result with a different direction? Yeah. Great. Change that to FR, and then what do we do for the last part? Switch the ratios, 3 to 2. So we switched the directed line segment, and we switched the ratio. Really nothing more to it. And good job there. So we can answer the next two really right away. So directed line segment, so for the next part, what is it going to be? BA is the line segment, and the ratio is 5 to 1. And the last one, the directed line segment, will be QR with a ratio of 5 to 4. Yeah, so if you've done one of these, you get the idea. Now here's the thing. Moving forward, you will be seeing ratios like this. But we're not going to be working with ratios. We're going to be working with fractions. And so we want to convert these ratios into fractions. And let's think about just this last one right here. So if I'm going from Q to R and it's split into 5 to 4 ratio, what fraction of the distance is it from Q to R until I get to the partition point? So what fraction of the way? So it's going to be some kind of a fraction right here. What might my numerator be? 5. And what do you think the denominator is going to be? However many parts total there are. So out of how many parts total are we going until we get to the partition point? So 5 over 9. So it's 5/9 of the way. So again, you can see there's 9 total, and we're going only 5 of them, so that makes it 5/9 of the way. Does that make sense? Okay, so here's the general form for this. If you've got a ratio, and you can write this down at the bottom, if you've got a ratio of A to B, and you want to convert this into a fraction, then your fraction is just going to be A over A plus B. All right, so let's try that with, starting at the top of the page, let's try that with some of these. All right, so a 1 to 2 ratio, I'm just going to take, that would be like my A and my B. So it's going to be A over A plus B. So that's going to be 1 over 1 plus 2, which is 3. So 1/3. All right, what's the next one going to be? 3/4. Okay, so see if you can convert these into fractions, and we'll talk about those in a second. All right, so the next problem. We had 5 to 1. What is that fraction going to be? 5/6. Okay, the next one, what is it going to be? 2/5. The next one is 1/2. And the last one is 3/5. Okay, so for your purposes, if you can do this conversion and you can remember how to do this, this is one part of the process you're going to have to go through for our this particular content that we're covering. And so this will be one of the questions on the test. I'll give you a ratio. You have to convert it into a fraction. If you can do that, that's worth part of the points. Okay, so now let's see what we're going to be using this for. And I have to come out with another handout for you. So you guys are looking at this page. It should match up. And the first thing that we want to do is identify, we're looking at a directed line segment for this. And we want to identify which one's first and which one's second. So it's directed line segment AB. We're going to start with A and go toward B. A big reason why people make mistakes on this is because they don't read that. And they do this entire sort of partition going from the wrong end. Okay? And the next thing, of course, is we want to convert from a ratio into a fraction. So 1 to 5 is going to convert to what as a fraction? 1/6. And the question was asked, is it always the first number as the numerator? And it is always the first number. Okay. So we have a 1 to 6 fraction, not 1 to 6, but 1/6 of the way. So let's go ahead and plot these points, and we'll see what's going on. So A is at negative 10, 4. Oops, didn't want to do that. There's A. And B is at 8, 4. So this works out really nicely in that it's a straight line going across. So like I said, we start off with some nice problems, and then problems get not so nice later. But we're just going to stick with the nice problems for today. All right, so the idea is this is not broken down like before, where it's this nice segment with all of the partitions already drawn in there. We just have a segment that starts at A, goes to B, and we need to find a point 1/6 of the way. All right, so maybe the first thing we can do is figure out what is the total distance we have from A to B. And what is that? 18, yeah. You count this up, and you've got 18 right here going across. So we want to figure out a distance, or we want to figure out a point that's 1/6 of the total distance. So what do we do with that? We know it's 18 across. We know we want to find something 1/6 of the total distance. So what do we do? There you go. We just take those and multiply. 18 times 1/6. And remember, anytime you're multiplying and you have a fraction, you can just move that whole number up into the numerator. So it's going to be 18 times 1 divided by 6. And what's our answer here? 3. Yeah. This one's not complicated. Not bad. Okay. So if you've got 3 going across, that's not our final answer. What we're saying is that we need to go 3 spaces away from our starting point. You can leave it in the tray. We need to go 3 spaces away from the starting point, and that's where we'll find our partition. So starting at A, I want to move 3 over. All right, so I'll just count over 1, 2, 3. And that leaves me my partition point right here. So your final answer for these types of problems is going to be what's the coordinate for the partition points? And so what's our final answer here, the coordinate? There it is, -7, 4. All right, and just to show this and make it look a little bit more like yeah. 1/6 was from the ratio, that 1 to 5 converted into 1/6. Remember, A over A plus B. Yeah. And we can make sense of this. This one works out kind of nicely. We've got 1 part until we get over to our partition, and then we got 5 parts after it. So all of them should be the same. So we've got, I'm going to split this into sections of 3. Notice that I've got 1 of them over here on the left, and I've got 5 over here on the right. So that looks a little bit more like what we were looking at earlier. Now, you don't need to draw those partitions in, but it does kind of help to connect it back to what we were doing. So that point P is now at -7, 4, and it is 1/6 of the way from A to B. Okay. So let's just do the next one, and we'll call that good enough for today. The next one is a 5 to 3 ratio. In fact, what I'm going to do is I'll just draw the 2 points on here. So it goes from -3, 9. So there we go. There's A. And B is at -3, -7. So here is your line. And we are going to convert the 5 to 3 into a fraction. What's that going to be? 5/8. If you know what you're doing, just go ahead and go through the process on your own. I was going to have everyone do it on their own, but there was something I wanted to mention real quick, which is that it is possible to have negative movement, okay? Remember, you're moving on a coordinate plane. So if you're moving down, that is going to be negative movement. If you're going to the left, that's negative movement also. So we need to understand that. Now, in this case, what's our directed line segment called? BA. We're going from B to A. Is this positive or negative movement? So we're going positive in the y direction. So count that up, and you can keep it a positive number. And what is that length? It's 16. Yeah, so from B to A, we're actually going 16. The other thing I wanted to mention real quick is once we convert into a fraction, if you can simplify the fraction, go for it. So let's say I gave you, and I'm jumping away from this problem for just a second, but it's something I wanted to mention. Earlier we had a 2 to 4 ratio. So when we convert that, it becomes 2 over 6. You can simplify that and make that 1/3. You don't have to keep it in the numbers that you're given if you can simplify. So I just want to make sure that's really clear. So anyways, we've got 16 for the total distance. We want to go 5/8 of the way. And we already talked about you just multiply those together. And did anyone get an answer there? Okay. It is 10. And I just use my calculator for these types of calculations. If you can do this stuff in your head, that's all good. But it can get more complicated where you don't want to try and do it in your head. All right. So 10. So what do we do with that 10? We go 10 up from B. So I'm going to count up, and there's 10 right there. And that gets me to my partition point. Now I can say I've got my final answer here. What's my coordinate for partition? The partition. -3, 3. Okay. So those two are good to go. I wanted to stop here because tomorrow I'm going to introduce kind of the process we go through when it doesn't work out nicely. Like when you have a diagonal line and it's not splitting evenly. So that requires just a little bit of a process, and hopefully the process makes sense. But we're going to stop here for today. And you have a little bit of time, but yeah, that's where we'll stop.